Hello, my name is Richard Culver with Animation Renaissance. The following is a summation of graphic asset workflows I've been developing and perfecting over the last 10 years in the game, simulation, and VR industry, focused primarily on best practices with recent clients using Unity and/or Unreal Engine as a production platform. In this series, I will go over all the aspects of production, from the very first ask or request to the final delivered product in the game engine or rendering pipeline. And with that, let's begin. The process starts with a project that has existing design parameters or a project in which design will be a part of the request. An art asset is any element 2D or 3D that will be in the view of the user. The first phase of the project is to obtain or create the design parameters and any specifics of the need. This can be accomplished in any number of ways, but the end result will be a statement of need and objectives of the project or particular asset. It is often the case that in order to determine final design parameters, prototypes are made to test functionality and plausibility of the project or asset need. If an asset creation studio or artist is employed to create prototypes, it is vital to understand that this is not a candidate for design review and should never be considered a statement of final design or style decisions. Prototypes only exist to inform design functionality and project objectives, from which final design and style decisions can be made. Prototyping can be part and parcel to informing design parameters in any kind of project, realistic or creative, and it may also integrate with the next step, which is the research phase. The next phase is the discovery or research phase. For creative design, this is research of existing art, real-world objects, or real-world technical counterparts to the creative request. In the case of reproductions, it is the acquisition of adequate reference material or technical data, not the least of which would be the objects themselves for review. Entering the design phase, then, we assimilate the research data and begin our design of the creative project based on the parameters of the request. In the case of a reproduction, we make the pertinent reference material available to the artists in a form conducive to moving forward with accuracy. All of the steps up to this point can be highly iterative and cyclical. Each of the phases up to now can inform each other. The research phase might uncover oversights in design parameters, and the design phase may show room for improvements in research or even highlight the need to revisit the request. The request may also be modified by unforeseen factors, which have a ripple effect down through this process. Prototypes have a brutal tendency to knock down preconceptions and can highlight weaknesses in any of these areas. It is important that the larger changes and iterations be dealt with here, and not brought forward into the production phase, which is far less forgiving to fundamental changes. The production phase is broken up into a linear series of steps, one following the next, in a necessarily rigid process that can be categorized in the following past the point of no return milestones. The initial design realization for a creative asset usually starts with two basic forms or a combination of the two. The first is a free-form organic or hard surface model that is realized in a free-form sculpting application such as ZBrush. The second type is a model realized in a polygon modeling application such as Maya, Blender, or 3D Max. Reproductions start as engineering files when available. Sculpted models, or reproductions from CAD files, are usually too heavy in system resources to be used in any animation, game, or VR media application, because they are created or exist originally in a form that best realizes the design without respect to performance. This is the first milestone point of no return. It is important that any stakeholders sign off on this phase as the design realization complete before moving on. Making changes here, after the next phase has begun, will break that next phase in most cases. In either of these cases, creative or reproduction, the next phase is a process of optimization which begins with what is termed retopology. In other words, replacing the higher resolution source CAD file or sculpt with a lower resolution mesh. This is usually done by hand or using specific remeshing algorithms designed to create clean meshes. It has been our experience that decimation methods are not efficient and more often than not break the mesh or make them inadequate for later phases of the pipeline. So it should be noted that decimation should not be used on a graphics model that will need rendering in a scene. The end of this process, in all cases, is a point of no return milestone where the mesh is ready to be prepped to have the details that were lost in the retopology optimization phase added back to the model in a way it can be rendered in a game or VR environment. This is done with textures, usually image maps. This is an absolute point of no return milestone. Coming back to this step after the texture process is complete, we'll break the texture link to the mesh. To prep for the 2D texture process, the mesh must be embedded with data to convert the surface area of a 3-dimensional object into 2-dimensional texture data represented on a U and V direction grid. This process is called UV mapping. Once the UV maps have been created, both the high-resolution and low-resolution meshes are brought in proximity to each other in a 3D application, and the high-resolution details are projected or baked into the low-resolution optimized mesh by way of images that are projected on the 2D grid embedded in the object data. The image maps are then used in the game or VR environment to simulate light, occlusion, and relief details. Once the baking is complete, further color and material properties, as well as wear and tear, decal, or relief details are painted on the model in a program such as Substance Painter. These attributes are then stored on the UV grid in the form of image maps that are exported to the target game platform or render engine. The final asset mesh is exported to a format such as FBX and imported into the game engine. The image maps are imported and applied to a material in the appropriate slots to complete the look of the intended creative design or real-world reproduction. Assets that require animation are usually animated in an external application such as Maya or Blender. The animation data is embedded into the FBX file during export. Once in the game engine, the asset is set up to have animation applied during runtime. After an asset has been imported into the target rendering pipeline or game engine, there are further steps that should be carried out by a graphics artist. Scene setup and optimization, lighting, shading, and post-processing are all necessary components to the final product, and should be done by artists or technicians with experience in these areas. A graphics production pipeline is a delicate combination of careful planning and the ability to deal with unforeseen challenges and changes. However, with a good production plan and a solid grasp of the basics within this presentation, it should help artists, producers, and managers alike to better understand this process and avoid unnecessary blocks, double work, and inefficiency. I thank you for your time and best of luck in your next project.